Hi, so today I'm going to show you what the latest WindCFD 2026 beta is able to do. So for this demonstration, I'll just import a sample IFC model that I've got here, so we can import IFC models directly, as well as object files and also IGES files. So once we've got the model imported, that's what it looks like. We will set our wind direction using the compass tool here at the bottom right. So we'll say the wind comes in a northerly direction, and we can see here from our UCS icon, north is going to be in that direction, and the same in the view cube. So we'll have the wind running across the back of this wall here on this rectangular structure that sits in front of this circular structure. Now, of course, I chose the structural IFC model. It doesn't have any cladding or anything like that, so we'll just assume that it's all open for whatever reason. Of course, I could have used that architectural model as well. It's irrelevant. The geometry doesn't matter. You can import anything from small models to massive scale models. Now, the first thing we'll do here is we'll classify these obstacles, because you might have different kinds of elements within your environment. This is just a small model, so I'll just set everything to building. Notice we've also got no topo surface or terrain in this model. You could, of course, have that, and that'll affect the way the wind behaves. And this one will just assume that there's no terrain specified, which means that it'll just create a flat terrain at the bottom of the model. On our setup settings here on the right hand side, let's just maximize or make this a bit larger. We see that we've got a wind speed, an inlet wind speed of 20 meters per second. I'll just leave that as is. The directional degrees in all directions, what that means is if I switch all directions, it'll actually run the analysis not just in one direction, but in increments in 360 degrees of 15 degrees increments, 45 or 90, so I can check in all directions at the same time if I want to. I won't do that for now. The resolution, this is just the resolution and the density of the voxel size of the model that it's going to generate. Think of it as the resolution in an image, except that this is in 3 dimensions. Then we've got slices in the XY plane, so that is the horizontal plane. So against that, so that means the levels. So we're going to have 18 of those, and in the XZ plane we're going to have 24, and that's automatically computed. Of course, we can adjust these values if we need to, but I'm just going to leave them as they are. The height, also what level height should be included. We want a little bit of a gap or a tolerance above our structure maximum Z, so that we can have a bit of clearance for the wind to flow over that and compute that as naturally as possible. We've got padding on the in and outlet, so we know that our inlet's going to be here and our outlet's going to be there. So we've got a 30-meter padding, and then on the sides we've got 15 meters, which should be fine. We're going to use an atmospheric boundary layer principle, meaning that we set a reference height and an alpha value there that depends on the surrounding area. Is it light urban, dense urban, or whatever the case might be? And that will affect the wind profile, of course. If we switch that off, it'll just assume a uniform wind across the whole height. And then we've got some different tools or providers here for generating the back-end voxel data. There's a geometric slicing method, there's a mesh voxel, and then hybrid, which is a combination of the two. We'll just leave all of this as default, and we'll start building that. So what we do is we click on this build button here. It runs through really quickly, and it starts building that domain. The next step from here is we want to run the actual simulation. So I'll just adjust the window sizes there a little bit so you can see, and I'm going to let this run in real time so that you can see how long it actually takes to run through this. It's extremely quick. What it's doing now is it's preparing all of the domain information. It's creating the voxel backend. Remember, this is meshless, so it's not generating a volumetric mesh at all. We use a very unique approach called the quasi 3D CFD approach that we've developed with the GenFEAX solver that plugs into WindCFD as well as ConnectFEA and also in GenFEAX. So there we go. It's finished. In the time it took me to say all of that, it literally finished the complete CFD for that entire domain. And we can see that It includes things like vertical coupling, so we can see the profile in both directions flowing around that building. We can see the wind profile action here in terms of the surface pressure. So the color map we see here on the output is the surface pressure, and then of course the streamline coloring that we see for those streamlines is the velocity here, represented by the legend at the top left. And then on the pressure panel on the right hand side, we've got some summary result outputs. So really easy, really simple, doesn't require any complex model setup. We do away with meshing, which is often the deal breaker in these kind of problems. And it also means that we can work with very complex geometries regardless of size, geometric size, and also in the size it takes up on your hard drive or your graphics driver, for example. So really powerful, really fast, and really cool. Thanks for watching. Talk soon. Bye.